Let's do another example of solving radical inequalities. So again, if it contains a square root and an inequality sign, that's what we're talking about. I'm going to follow the same steps we did for example 1. Here we have square root of x minus 5 is greater than 3. Again, we want to try to figure out what numbers for x would make this inequality true. I believe my guess would be something like maybe 20, right? Because you'd have the square root of 15 if you plugged in 20. And square root of 15 is bigger than the square root of 9. So yeah, that's a number that works. But we want to know all numbers that work for x. So again, we're going to do the same steps. Step 1, we're going to set the inside of each radical equal to 0. That just gives us our possible test values. It doesn't solve anything. So what's inside the radical? X minus 5. So according to this step, we're going to set what's inside that radical equal to 0. Add 5 to both sides. X equals 5. That's a number, it's like a place marker we're going to put on the number line. Step 2, we're going to change the inequality to an equality, just an equation, and solve the equation. And again, this just gives us another place marker on the number line to figure out our test values. So it was greater than 3. We're just going to change that to an equal sign and solve for x. We're going to square both sides to cancel the radical on the left, and now we have x minus 5 is equal to 3 squared, and then add 5 to both sides. X is equal to 14. So x equals 5 is one of our place markers, x equals 14 is the other one. We're going to put that on the number line. So here's the question. Why do we have a whole, did I say 15? I meant to say 14. So we have x equals 5 and x equals 14. Why do we have a whole at 14? Well, this is greater than, right? It's not greater than or equal to. So in our final answer, when you're dealing with radical inequalities, it's going to hinge on this number, this symbol right here. There's no bar here, so it's not going to be a solid point. It's going to be a whole. So step 4, we're going to choose our test values for each interval on the number line. Just pick a number to the left of 5. We'll go with 4. Something between 4 and 14. Sorry, 5 and 14. Why not 6? It's just to the right of 5. And by the way, we do want these numbers to kind of work. And 6 is going to work because the square root of 6 minus 5 is square root of 1, which is just 1. So yeah, you do want to try to be selective. If you were to choose like 8, you'd have the square root of 3, and we don't know what that is. So yeah, be selective when you choose these numbers. And then something to the right of 14, bigger than 14. Well, again, if I just did 15, I'd have the square root of 10. That's not going to work. So I chose 21 because 21 minus 5 is 16, and the square root of 16 comes out to 4. So again, you need to be selective about those numbers. Step 5, plug those test values into the original inequality, which was the square root of x minus 5 is greater than 3. So first test value, I'm going to plug in 4 in for x, then I'm going to plug in 6, then I'm going to plug in 21. So over here we have the square root of negative 1, which doesn't work, so that's no solution. So that 4 that I plugged in tells me, since it's no solution, this will not be shaded to the left of x equals 5. If I go between 5 and if I go between 5 and 14, I'm going to plug in 6. Square root of, this is going to be 1. Square root of 1 is 1. That's not bigger than 3. So I'm not going to shade this part of the number line either. And finally, we're going to plug in 21, which is to the right of 14, bigger than 14. We get the square root of 16, which is 4. And yes, it is bigger than 3, which tells us we're going to shade to the right of 14. Step 7, shade the sections of the number line in which the test values are valid. So we will shade anything to the right of 14. I should have drawn an arrow there. Don't know why I didn't. So anything bigger than 14 will work, meaning that for step 8, when we write the solution out, x is bigger than 14. If we go back to the original inequality, yeah, if we plug in anything bigger than 14, it will work. You might be thinking, what about 14? Well, again, 14 minus 5 is 9. Square root of 9 is 3. 3 is not bigger than 3, which is why there's a hole there. But certainly anything bigger than that will work. That's it for this example. If you have any questions about it, let me know.